At the beginning of previous episode, I said that the font of RStudio or R may be too small for some of you, and I realized this after recording that episode, so sorry for this. Now I believe that I fixed this, and last time we talked about very simple arithmetic operations that we can use with R, and assignment operators, and how we can or we cannot name our objects. Yeah. Now we will move beyond and above those topics, and we will start with trying to run some commands completely outside the R environment. What I mean by this? So, in all Unix-based systems, you have console. In Windows, the equivalent of this is PowerShell or command prompt. Yeah, it depends on the version of Windows. Yeah, so here this is console in Mac OS. Yeah, and here we have we can communicate with this operating system by command line. Yeah, ls list. This provides us the list of the folder where we are. pvd is this command shows. This is equivalent of getwd from R, and it shows the current working directory. Yeah, and you can do a lot of stuff using terminal, but the purpose why I'm showing this to you is to show you how to make the same thing but inside R. Yes, so in R there is command called system, and here as an argument we provide a string inside which there is a command that we want to run. For instance, if we want to show the content of the working directory, it is equivalent to this. Yeah, the result is exactly the same. Here we type ls. We have a list of files and directories inside users Pytka, and if we type the same thing here, now we will get error message, because this must be surrounded by quotation mark. Yep, and now you can see files that I have in my working directory. Yeah, okay. Now I needed to jump a little above, because we will need the space down there in the next exercise, and so we can run any commands we want inside R, but what is much more convenient is to use some predefined commands, or alternatively we can install new components. Yeah, that if we need those components, we load certain library that runs certain operations. Yeah, and we load this library if and only if we need this. Yes, so thanks to this trick, we keep in our memory only the most basic commands, but and use those more sophisticated ones only if we really need it. Yeah, and Yeah, this is standard in I would say in all programming languages. Yeah, in Python this is even more extreme than in R. Yeah, and because in Python, even making arithmetic operations, yeah, to start doing this, you may need to load some packages. Okay, but here we will use the package called Caussay, and we load a new library from the set of libraries that is downloaded to our is downloaded on our computer. We load this by using library and the name of the package. Yeah, and now it won't work. It works. Okay, we had one tiny technical problem. So now let's do it once again. And now it doesn't work. It doesn't work because we don't have this package downloaded. Yeah, and to download new packages, we use command install packages, and as an argument we provide the name of this package. Yep, and after running this, R communicates with the server of the server of our developers, and it downloads this to our computer. So now it doesn't work as we don't have it yet. And now it works, hopefully. Yeah, before it worked because I had this package installed. Yeah, so this is how we install packages using this command. Install packages, the name of the package, and library. This command is used to load one of our libraries that we have installed on our R. So now, after loading this package Caussay, we can start using new commands. Yeah, and in the case of this particular package, help Caussay, command help provides us information about certain package, just like here, Caussay, or commands. Yeah, so it's documentation that it's good to read very carefully for many packages. Yeah, so here it's written, and also, by the way, yeah, that's the reason why we need this space down there, because I would overlap with this help viewer. Yeah, so now here we can read that there is this command say, new command, and we can write say what? Hello world. Hello world. And after running this code, yeah, it generates this this cat that says hello world. Yeah, so here what is important is that we provide the name of argument, what is equal hello world. Yeah, also it will work if we provide only this, also it should work. Yeah, it worked just fine. But what if we want to use, I don't know, some other animals to say hello world? So then we use help, say, and we read documentation. Here we see the description of this command, say, and possible arguments. Yeah. So here we can write say what Mannheim. Yeah. And if we want to provide additional arguments, we write comma and additional arguments. Yeah, so for instance here by, this is default option. If we don't provide by, it will be a cat, just like here. But we can also, why not? We can provide this, and this won't work, I guess, because it must be in quotes. Yeah, grumpy cat. We can combine many options. For instance, it's almost summer. Yeah, so all of us miss snowmans. And yep. And for instance, also we can change color. What color is equal to? Here this text is blue, and we can use red color. Yeah. Also, as I said before, R ignores spaces, but also it ignores break lines. So we can write this way, and also it will be the same as everything in one line. And this is more, it's easier to read such a code for many people. Yeah. Okay, so this is it. Yeah, and this is snowman. Yeah, let's say it's snowman. And as expected, this text is written in red. Yeah, so this is it. Yeah, and yeah, and in particular, yeah, I'm not saying that this is the most useful function. Yeah, but it's a good exercise for practicing working with commands. Yeah, and yeah, and this is it. Yeah. Okay, so now we can talk about objects that will be much more useful than the snowman. Vectors. Yes, so vectors is this type of objects that this is mathematical vector. Yeah, and in R, to create a vector, we use command C, which is abbreviation for concatenate. Yeah, and if we want to create vector, numerical vector of few numbers, we type this. We separate elements with comma, and we have vector, numerical vector with those 4 arguments. Yeah. At the same time, we can create vector of characters, just like here. Let's say das. Why not? Yeah, and all in the first case here, all objects, all elements are numerical. In this case, all types are characters. Also, all elements are of class character. Also, yeah, we have the third class, true, false, true, yeah, and we will get a vector of elements of class which is logical. Yeah, What is important in the world of vectors is that all elements must be of the same class. Yes, so what happens if we write weird vector, for instance, there2? Yeah, we won't get an error message. Instead of this, we will observe coercion of classes. Yeah, and here, because one element of the vector is character, one element is numerical, are automatically converted numerical type to character. Yeah, and we can put many numbers. Yeah, and it's enough to have one single element which is of different type. If there are all numerical elements and only one character, all elements will be characters. Yeah, similar thing we have with another vector with logical elements and numerical elements. Yeah, so here and as you see, true t was converted to 1. Yeah, just as a reminder, true is 1, false is 0. Yeah, so again, here it's enough that one element is numerical, then all elements that are logical are converted to numerical counterparts. And what happens if we combine 3 elements? In this case, it will work that all those guys will be converted to characters. Sorry, I forgot to technical break. It was yes. So now we have what happens if we combine all classes: character, numerical element, and logical element. Yeah. So yeah, all elements are character now. And also notice that true is not converted to 1 and 1 to character, but it's converted directly. By the way, I'm now quite curious what happens if we type this way, whether this element will be character t or character true. To be honest, I don't know. Let's see. Yeah. So, but overall, yeah, you have to remember that in one vector can contain all. In each vector, all elements must be of exactly the same class. Yeah, and if it's not the case, then some classes are converted to those more, I would say, more tolerant classes. Yeah, and this is it about very short introduction to vectors. Yeah.